Imagine a place where the stars stop shining and galaxies decide to disappear. What could be hidden beyond this new boundary? Are we about to discover the biggest cosmic secret? Or is this just the start of a new adventure in space? Well, it seems the James Webb Space Telescope has found what could be the edge of space itself. Yes, you heard that right, the final frontier might not be as infinite as we thought. But wait, how can space even have an edge? Wasn't it supposed to go on forever? Let's explore what's really happening. When I first heard this news, I was excited to uncover one of the many mysteries of the universe. The James Webb Space Telescope has been doing just that, and it's turning our understanding of space upside down. In just 12 hours of observation, this incredible telescope showed us things that left us amazed and puzzled. Okay, let's imagine how vast the universe really is. Picture it as far as your mind can go, reaching the very edge of space. Now, let's find out what the James Webb Space Telescope can actually see out there, the real deal. So let's hop into our imaginary spaceship and not waste any more time. We zoom past our solar system, passing planets like Mars, Jupiter, Saturn, Uranus, and Neptune. We travel 100 astronomical units, and we're at the edge of the solar system. Beyond this point, we enter interstellar space, where the Voyager spacecraft have gone. Next, we reach the Oort cloud, a huge cloud of asteroids 200,000 astronomical units away from Earth. It's spread out so we can easily fly through it, entering total darkness. As we zoom past stars and planets, we reach the edge of our galaxy in just minutes. There's no more wind from nearby stars, just bright dots of other galaxies showing us the way. We realize that our universe isn't infinite. It has an edge 10 billion light-years away, and there might be other universes out there. The original supervoid, a giant empty space, could be proof that our universe collided with another. But how do we get to these other universes? Black holes might be the answer. These mysterious objects bend both space and time. Some scientists even suggest that white holes might exist, the opposite of black holes. These could lead to other universes. Do you remember the Little Bang from 2006? That strange burst of energy might have been a tiny white hole quickly destroyed. Now let's talk about the Andromeda Galaxy heading towards us at 68 kilometers per second. Don't worry, it won't crash into us tomorrow. But when it does, things will get interesting. We might see stars collide, or maybe our solar system will be tossed into dark space, like a ball thrown on a rope. Fast forward and the galaxies merge. Their central black holes will eventually combine into one huge black hole, sending out energy that we can see from millions of light-years away. Then, there's the South Pole Wall, 500 million light-years away, filled with a quadrillion stars. There's also the Hercules Corona Borealis Great Wall, a huge structure 10 billion light-years wide. And don't forget the giant large quasar group, which is 4 billion light-years wide and 6.1 billion times heavier than our Sun. Finally, there's the observable universe with over 500 billion galaxies, each with billions of stars. But wait, there's a void called the Eridas supervoid, or the cold spot that's a billion light-years wide. Some think it's the result of a collision between universes, two bubbles meeting and tearing material away. Picture the universe as a giant bubble, and there may be infinite bubbles, wormholes, or portals. Black holes could be shortcuts between these universes. Imagine folding a piece of paper to connect 2 points without crossing the whole page. That's the idea. Speaking of black holes, falling into one might not be deadly if its gravity increases slowly, avoiding the stretching effect we call spaghettification. Who knows? Surviving the fall could send you into a different universe with different laws of physics. But for now, that's just a wild idea. Imagine you're outside on a clear night, looking up at the stars. They might seem spread out evenly, right? Well, it turns out that's not true. Those stars are part of a huge structure, a giant cosmic web that connects galaxies. Using the James Webb Space Telescope, astronomers have just discovered what could be the oldest part of this cosmic web. In 2 studies published in the astrophysical journal Letters, scientists reveal this amazing discovery. They used data from the James Webb Space Telescope to find a massive filament of 10 closely packed galaxies, stretching over an incredible 3 million light-years. Shani Danieli, an astronomer from the University of Arizona and part of the team, was amazed. saying, "I was surprised by how long and how narrow this filament is. I expected to find something, but not something so long and thin. It's like finding a hidden treasure in the universe." This ancient filament of gas and stars dates back to just 830 million years after the Big Bang. That's when the universe was still very young. And what's holding this giant thread together? A supermassive black hole, of course. This black hole is not just any black hole. It's a super bright object that anchors this cosmic structure. The team behind this discovery is part of the ASPIRE project, which stands for a spectroscopic survey of biased halos in the reionization era. Their goal is to understand how early black holes influenced the growth of galaxies. So, how did they find this ancient filament? They were looking at one of 5 early universe quasars. Fan Wang, an astrophysicist from the University of Arizona and the leader of ASPIRE, is excited. "This is one of the earliest filamentary structures ever found near a distant quasar," he said. "It's like finding a cosmic map of the universe's early days." The researchers think black holes played a key role in forming this cosmic web. Imagine black holes as magnets, pulling matter together with their gravity. But sometimes, they send matter flying away with powerful cosmic winds. Gravity is the glue that holds these strands of stars and dust together, even as the winds try to pull them apart. So what will happen to this ancient filament? The researchers believe that over time, it will form a group of galaxies, like the Coma cluster, which is 330 million light-years away. It's like watching the universe slowly build itself into something complex over millions of years. When the James Webb Telescope looked at a small patch of the sky, it saw way more light and galaxies than expected, not just any galaxies but big, bright ones. Now scientists are trying to figure out what this means. They have a few ideas. One possibility is that stars and galaxies formed differently in the early universe, maybe more quickly and efficiently. Imagine a dark room where stars can form faster because there aren't many stars or galaxies around to get in the way. This idea is surprising but not totally new. Another possibility is that the brightness comes from supermassive black holes, not stars. Maybe we're looking at galaxies lit up by these huge black holes, which would challenge what we thought we knew about the number of these monsters in the early universe. The most extreme possibility is that our understanding of the universe's creation, called cosmology, is wrong. It's a bold idea, but it could change everything we know. The most extreme idea is that there's something in the universe we haven't even thought of yet. Now, why does all of this matter? Well, it's about finding our place in the cosmos and understanding the story of how we got here. If we're missing something crucial in this story, it's like trying to solve a puzzle without all the pieces. And the more we dig into this mystery, the more questions pop up. Recent findings from the James Webb Telescope have given us a reality check about the size of the universe. Like, we might have been way off. Scientists dropped a bombshell in a recent paper claiming that the telescope caught glimpses of stuff just 120 million years after the Big Bang, if the Big Bang even happened. Moreover, it challenges the very foundation of the standard cosmological model. The universe might not be as old as we thought, and Einstein's idea of it being infinitely old turns out to have missed the mark. Our intuition has been playing tricks on us, and we're starting to think we don't really have a clue about what's out there. The James Webb Telescope gazes into space, trying to see as far as possible, but it can only reach about 46.5 billion light-years away. We call that the Hubble radius or Hubble sphere. And guess what? The most distant galaxy ever discovered by the telescope, the MAX 0647 JD galaxy, lived just 450 million years after the Big Bang and is still within this Hubble sphere. Now, our universe is like a balloon that's constantly getting bigger. Not only is it expanding, but it's also accelerating in its expansion. Beyond the Hubble sphere, the universe is stretching out faster than the speed of light. But the Hubble sphere won't keep growing forever. There's a cosmic horizon limit, a fancy term for the observable universe. Imagine a gigantic imaginary shell around us, 93 billion light-years wide. That's our limit, the farthest we can see. Anything beyond that? Sorry, not visible yet. Even if we had the craziest telescopes, the light from there just hasn't reached us yet. So how big is the entire universe outside our cosmic shell? Well, we don't know. There are competing theories, and math gives us a run for our money. Some say it could be infinite, while others throw around numbers like the universe being 10 to the power of 122 times larger than what we can see. But the distribution of matter in the universe and the even spread of temperature in the cosmic microwave background radiation suggests that our universe might be infinite. Yeah, you heard it right, infinite. Mind blown already? When we gaze into the vastness of space, we're not just looking at distant galaxies. We are sort of peering back in time. Those galaxies we see near the Hubble sphere, they're not snapshots of the present. They're like cosmic fossils, remnants of a bygone era, billions of years ago. It's like having a time machine, but instead of traveling, we're just looking really, really far. According to our cosmological model, about 14 billion years ago, the entire observable universe squished into a tiny point called the singularity. Well, that's the standard story if the universe is finite. But if it's infinite, which it kind of seems to be, then the Big Bang wasn't a localized event. It happened everywhere. Now, the first galaxies didn't pop up in a specific neighborhood of space. They were the universe's grand opening act, happening everywhere, even beyond what we can see. The big question, though, is, what kicked it all off? What or who created everything out of nothing? Einstein was initially against the idea of a Big Bang. He liked the idea of a steady-state universe that had been chilling forever. But equations have a persuasive way of changing minds, and eventually, he hopped on the Big Bang bandwagon. However, some people, including our friendly scientists narrating this cosmic tale, think the singularity isn't the start, but more like a universal birth certificate. Just when we thought we had the universe's biography sorted, the James Webb Telescope came and blew our minds. It recently stumbled upon F200b45, a galaxy that could rewrite cosmic history. This galaxy is so distant that, if confirmed, it would challenge our cozy 13.8 billion-year-old universe narrative. Now, Webb has found galaxies that shouldn't exist. I'm talking about massive galaxies appearing just a few million years after the Big Bang, a cosmic speedrun that defies our current understanding. Even more jaw-dropping, the telescope caught early black holes only 700 million years after the Big Bang, black holes merging left and right, possibly explaining how these cosmic vacuum cleaners grew in their toddler years. These discoveries are stirring up some cosmic chaos in the world of cosmology. The universe might be older than we thought, or it might not have had a beginning at all. Imagine if our universe is like that favorite storybook that never had a first page. It's always been there, just unfolding through different chapters. As we peer deeper into space, the idea of an infinite universe starts to make sense. If the universe seems infinite in size, why not infinite in age? Maybe the Big Bang was just a plot twist, not the opening scene. And it's a big but, we need more research. Does this eternal universe vibe jive with our current scientific groove? Can it explain the intricate dance of events during the Big Bang? There might be around 2 trillion galaxies out there, but astronomers are scratching their heads, wondering how much more of the universe is out there beyond what they can see. Virginia Trimble, an astronomer from the University of California, puts it like this: the universe has always been slightly larger than what we can see. It's like the universe is playing hide and seek, and we're desperately trying to figure out where it's hiding. John Mather, a Nobel Prize-winning cosmologist from NASA, breaks it down. We've already seen as far as you could possibly imagine. At the very edge, we catch a glimpse of the afterglow from the Big Bang. And it's a big but, this isn't the end of the line. The universe keeps going, and we might just never know. In their quest for answers, cosmologists have taken a leaf from the ancient Greek mathematician Eratosthenes' book. They're trying to figure out the shape of the universe to solve the mystery. Think of it like finding out if the universe is a giant saddle, a huge sphere, or a flat sheet. Now, the saddle-shaped idea doesn't have many fans, but a spherical universe feels cozy to us. Einstein dubbed this model a finite yet unbounded universe. But in the late 1980s, observations studying cosmic microwave background radiation dropped. Recent observations reveal that space is flat with no curvature. As John Mather describes it, it's like an endless sheet of paper. This flatness suggests that one could travel infinitely in any direction, encountering galaxies indefinitely. While this fits well with current astronomical theories, it raises questions about the universe's finiteness. Virginia Trimble notes the difficulty in determining if the universe is infinite, likening it to figuring out if a pizza is infinite or if it has an edge. This leads to contemplation about the universe's edge and what lies beyond, considering different curvatures and the possibility of a multiverse. Some theories propose the universe could be a bubble in an expanding multiverse, possibly with an edge and different physical laws on the other side. Astronomers seek a theoretical model to determine the universe's infinity, akin to the prediction of particles like the Higgs boson before their discovery.